Hey everyone, this is Adam Green here from ATA Engineering. I wanted to welcome you to this webinar and we're going to be talking a little bit about ATA and STAR-CCM Plus for just a few moments, and then we'll pass the ball to Matt Godo to Siemens.
Sure.
Matt, do you want to quickly say hello and introduce yourself?
Sure, happy to. Hopefully you can hear me okay?
Yeah, you sound good.
Great. Yeah, so my name is Matt Godo. I'm one of the product managers for STAR-CCM Plus, and I've got the responsibility for the platform department, which is one of 3 departments in our organization. The other 2 are discretization and physics. So if it's not one of those things, then it's my responsibility. And honestly, I get all the good stuff, including Screenplay, and that's part of our data analysis program group. And I'll be talking about that a little bit later.
Excellent. Okay, we appreciate that. So just some housekeeping for everyone else. We've kept everyone muted. Our experience has been that we get a little ambient noise otherwise, and so we'll keep everybody muted until the end. We'll have plenty of time for questions for Matt directly. So with that, I am going to get started. And welcome everyone. And so really the things we're going to talk about today, as I said, are pretty basic: an introduction to ATA and then STAR a little bit, and then pass the ball over to Matt to show us in a lot more detail, Screenplay, some examples, and really how it works and how to get started. And I hope after today, pretty much everyone on the line, and a lot of people on the line today are users, and I hope that STAR-CCM Plus users. So I hope that'll mean we'll get a lot of good questions from the audience at the end of this call. So please be ready for that with your questions. And so most people know ATA, but just to recap, we've basically got employees around the country in the US of more than 150, a really very high-end team of PhDs and masters and some bachelors as well, but really a very kind of elite services team servicing a lot of various industries, including kind of aerospace, robotics, and also themed entertainment is a new one for us too over the last 5 years for looking at kind of structural integrity of themed entertainment rides, which is quite an intense industry as well. So we do dabble in some others, but the top 3 across the screen there are the ones we focus on. Now, I put this slide in here not because I want to dive into in loads of detail, but I just want to make sure that everyone is kind of familiar with ATA's legacy to excellence, really, and really where it came from. So ATA in 2000 was created out of a team from SDRC, and I increasingly get a different response when I say to people, do you know who SDRC are, depending on how old you are. If you're over, say, 30, you kind of know who they are, but if you're not, some people don't nowadays. And so SDRC was Structural Dynamics Research Corporation, headquartered out of Cincinnati, with a services team in San Diego that ultimately in 2000 was sold off and made into a management buyout, which became ATA Engineering. Now, SDRC created ideas, created unit graphics, and created NX. And so ultimately, the creators of NX, which we all realize now Siemens own and use, and we support very heavily, came from SDRC, way back in the 70s and 80s. And so there's a long line of people in ATA who were actually back there in 2000 when that happened. So a lot of the team in ATA now go back all the way to SDRC. Not so many nowadays, but still some. So I wanted to get, and you can see since then we've grown steadily, and now we have offices, throughout the country, in really the key parts of the aerospace industries mainly. And we do a number of things. One is we do testing for really any kind of aerospace and structural problems. We do ground vehicle testing and vibration testing for large structures, looking at modalities and things like that. And we do design, and we also do analysis with pretty much all of the Siemens, mostly Simcenter tools, to do advanced CFD and advanced FEA. So we tackle the whole spectrum of things across the industry. And really, here's our locations. You can see headquartered in San Diego, offices in San Francisco, Denver, Huntsville is a big one for us, and then Albuquerque and Washington are our other offices. And key to that is that we're also a Siemens Platinum partner for value-added reseller, which basically means we resell many Siemens products, including STAR, including HEED, NX, VMAP, and many others. And we also support them, we consult with them, and more recently, we're also starting to teach classes for all of those as well. So Siemens have been changing the landscape a little bit over the last year, asking partners to start doing more support and doing more training for all products. We've done NX and VMAP for many years, but for STAR and for HEED and some of those, it's new for really everybody. And so basically after this, many of you already been there, and obviously as clients, you know that, but the website is a lot of resources where you can go and pick up things that, new information about Siemens and ATA. So I urge you to kind of revisit that from time to time. So this is an animation screen or visualization screen, I like to call it, that I put into a lot of my STAR-CCM presentations, and I like it because, well, primarily it's eye candy, and we normally get a lot of wow factors from it. But it also highlights the idea of why we need screenplay, and let me elaborate what I mean about that. So if you look at most of these videos here, not all of them, but certainly the two, I don't know if you can certainly see my mouse, but this one, and really all of them to start with. This one changes, but this one to some extent. Mostly the camera is always in the same place. It's really a series, so really most videos that people create with CFD are looking at either transient flows and loading in multiple transient data sets, but keeping the camera angle at the same. And that was straightforward, but you can see this one up here where the camera's moving around is a lot more elaborate, and was quite tricky to do in STAR. If I go to the next slide, you can see what I mean. So this is a regular video of an osprey, and it's fantastic in terms of the data that it gives you. But when you look at this, my first thought is, wow, that's fantastic, but I'd love to be able to spin around and look at the back of it to see what that flow is doing around the fuselage at the back, and maybe the rear wing and so forth. And as a static image or a static scene, really just animating the data, you can't do that. But nonetheless, STAR's been able to do this for a long time from the GUI. But if you really wanted to make it more, camera flexibility, you needed to turn to JavaScript. And this is a video that I actually created about 5 years ago when I worked for CD Adapco. And this is a motorcycle coming up to some water. The wheels are going to go around, and the water gets picked up by the tires and thrown around. But the difference is that the camera, simultaneously to loading in all of the transient data for the model, also rotates around the rider. And I think you'll agree the rotation adds a lot of value to the simulation, so that you get much more depth, you get much more understanding of the process. So instead of having a static view showing the same data, you get this rotation. Now, if you wanted to do that in STAR from, say, 3 years ago, you had to write a lot of JavaScript, and you had to sit there for probably 2 hours while it read in each data set, churned out the pictures, and created the animation. And so now with Screenplay, that's going to be a lot better. So I think that kind of sets the scene really as to why you need Screenplay nowadays, instead of using JavaScript and other tools to pull out exactly what you want, and really needing to become an expert at all of those things. Screenplay kind of opens it up so that hopefully everyone can use it from the GUI and get much more professional results. And with that, I will pass it to you, Matt, which means I need to stop sharing and you need to share. So are you ready to roll?
Adam, can you hear me now?
I can now, yes. Did Jonathan unmute you, or did you unmute you?
I was able to do it, so I was like, help, unmute me. So, sorry about that. Okay.
So now you can share your screen.
Yep. All right. So let me shift over. Adam, that was a great intro. You've already covered some of the themes that I want to share as part of this presentation today. And I'm assuming you can see my screen. It's coming up okay?
Yes, it's all good.
Great. Okay. So I just wanted to give some background and some perspective. And there's some interesting research out there that talks about how we perceive content. And there's a couple of interesting points here. For example, 90% of the information sent to the brain is visual. That's pretty interesting. And another interesting one that's actually been validated, visuals are processed 60,000 times faster than text. And yet another stat here, the average person reads only 20% of the text. So if you write a really nice blog, everybody's just going to look at the pictures. I think that's the bottom line on that slide. That's not a surprise at all, really, because visuals are really engaging, and that's a way in which we tell our stories. And one of the things I want to focus on today is how we tell the story of the simulation of our results and how we can communicate the value of those results. If we look at tools that we use, often we're using presentations, and visuals really give quite a boost to presentations. Key stat here, 40% of the people respond to visual information better than plain text. 65% of the people are visual learners. So again, that kind of provides some evidence for why it's important to be able to graphically illustrate your results. Last here, videos, and another way to say animations. But videos are what people are paying attention to now, and there's a lot of evidence on here to support that. One of the statistics that catches my eyes, that videos can be memorable. Right? You're more likely to remember a video than you are a still picture. And a lot of people are shifting to, all right, just let me connect to a video so I can actually see the point that you're trying to make. So there's a lot of evidence to support why it's important to spend time on visual presentation and animations. So the question might arise, well, why do I need Screenplay? Why do I need a tool to be able to make animations? And in this animation at Write, what we're looking at is a capability in STAR-CCM Plus called data focus. And that lets you apply filters to XY plots, and then to take those filters, what we've set up, and to impose those on pictures. So on the right-hand side, you've got your XY data, and we're plotting temperature and mass fraction of oxygen versus the mixture fraction. And we're using those filters on the flame illustration at left. And so you can see as we modify our filters, we see a direct link between the flame. So what we're trying to communicate here is I've got a combustion problem, and I want to find out if I've got unburnt fuel. And the selection of the data focus filters here can help me with that. Now I can modify the filters interactively with my mouse, but as I change those, I need to remember what the filter was set at the last time, just before I moved it, to connect that back to the picture in the flame front. I also want to look around the flame. Adam, you made that point with the Osprey. It's nice to get one view, but it's better to be able to just spin it around and get a peripheral view. But to do that with a Screenplay, I need to do a lot of mouse interaction. So as Adam said, yeah, you could write JavaScripts to do this. And 2 hours is kind of, I think, the people who are doing animations are probably spending even more time than that on it. And it does require a high level of authorship. You do need to know Java, and you do need to know some things about how to manipulate scenes and plots. The alternative now is to be able to use Screenplay. So you can very easily and quickly create shareable animation. And this particular Screenplay was fairly basic to set up. If we have time, I can show you what the storyboard looks like for this one at the end. But that's the idea. That's part of the motivation. Why, again, one of the reasons why we want to use Screenplay is just to grab the attention of your audience. You can do some neat things with an animation. You can communicate real abstract ideas. And if you've got a good concept in mind, you can actually do some nice simplification of complex concepts. In the animation outright, we're looking at a mixing tank, and we're using massless particles to track the flow patterns in this tank. And there's actually 3 subtle things going on here. There's the particles to show the flow, but we're also contouring the pressure on the baffles in the mixing tank at the same time. So we can see how that changes. So that's at least 2 layers of information. there's also subtle little motion in there to actually zoom in on the impeller blade as we pass back and forth. And the last little hook is to spin this in reverse. So again, the idea here is that you can make an animation that's memorable. It's arguably something of a Hollywood effect, but when you unwind a flow pattern like this, it might give you some additional insight into what's actually happening. So that's part of the idea and with Screenplay. And what I'll say is that an effective visualization is a lot like a good joke. If you have to explain it, it's not a good joke. And if you have to spend a lot of words to explain a visualization, it's not effective. So that's another thing to keep in mind when we compose these things. So Screenplay lets you do simple to complex things. So you can do a lot of different levels of animation. I want to stress a point here. We're not going for Hollywood, right? We're going for the effective communication of engineering results to show value. And yes, it helps if things look very appealing, but that shouldn't be your motivation off the top. If you can communicate a simple thing with Screenplay, that's a success. So to set up the discussion and to give you a little bit more of a glimpse on a how-to here, I want to walk through a little bit of taxonomy. And what you see at the bottom of the screen is actually the Screenplay UI. And the Screenplay is something that's associated with the scene or a plot, and we use it to organize actions. So this UI element at the bottom is really what the container or the storyboard for your screenplay. Within that, you can define actions. And the idea of an action is it defines when something starts, when it stops. So if you think of stage directions, if you're looking at an actor who you want to direct them to walk into a room, they have to open the door first before they go into the room. So that's part of what actions do. You can sequence things, and that's the idea. Next up, you've got the keyframe sequence. And within the action, this is the thing being interpolated. So in the previous animation, we were interpolating through transient simulation or solution histories, saved data for different time steps. And we were also interpolating a view back and forth. So this keyframe sequence lets you independently define where you start and where you stop in terms of your interpolation. So that's yet another thing. And within an action, you can actually have multiple keyframe sequences. The keyframes are the endpoints, so start and stop at the end. But you can also add intermediate points. So inside this action, you can make something more complex in terms of how it gets interpolated. There's a time cursor inside this UI. It's this horizontal orange-yellow bar. And you can use this to scrub back and forth between the sequence. So you don't even need to save an animation to get value. You could bring a colleague over and just grab this time cursor to go back and forth through your interpolation to be able to explain abstractions or complex concepts. Of course, there's the basic play controls and save out to file formats on this UI as well. So that's really the basis for it. In this sequence, I want to walk through a very basic pre-recorded demo. And here's how it works. Starting on the tree, you would navigate down to the entry called Screenplay. And you're going to associate a screenplay with an existing scene. You can actually keyframe things outside that scene as well, but you need to anchor it to something. Now I've got 3 solution views here, which represent collections of transient data. And I want to animate those. And what I do is I grab all 3 of them and drag them right into the Screenplay UI. There's a hint there on what you can animate, and that shows up as with that orange highlight. Once I've got these in, I can use my interpolation points to establish the range over which I'm going to interpolate. So in this case, I've got 360 steps that I want to interpolate. And here's the scrubbing action I described, where I can simply drag this slider across and look at how this screenplay animation evolves very quickly. So it gives me a way to preview or interrogate what I'm setting up. And that's really helpful when you're trying to set up an animation to say, all right, that sequence maybe needs to be longer. It's not quite lined up with other sequences. So instead of having to rewrite JavaScripts to line things up, you can do it interactively. So let's move on to some of the deeper level how-tos here. And what I want to show is a series of what I call one-action wonder screenplays. So from the UI, if anything's got this orange highlight, you can grab it and drag it straight into the Screenplay storyboarding tool. So I can just pick any one of these things and pull it straight in. In this particular example, I've grabbed opacity, or the transparency. And in the animation at right, what you can see is a sequence where I'm ramping this opacity down from being fully opaque to fully transparent. It's that simple. And I can interactively change the length of this sequence by dragging. I can introduce delays by moving my keyframes within that bar itself. So it's very interactive. And again, with the scrubbing tool, you get the immediate feedback. So let's break this down a little bit more. Right? In this particular screenplay, right, I've got this action with opacity. Now, if I click on this, it brings me back to the tree, right to the place where this action is. So the screenplay in this case is named Fade In. All right. I can click on the action here, that word right there, and that brings me to the action of interest. This is really helpful for navigating if you've got more than one action in this keyframe sequence. So I click on that, and that directs me to a point in the UI where I can now assess or change some of the properties. So I can change things like the time at which this starts and the duration. I can also turn it on and off. So I may want to preview things and then turn them off just to save time and get the storyboard together. Next step, I click on opacity, right, for this particular keyframe sequence. It drops me down into the properties. So here is where I've got the anchor to the tank wall, which was the thing that we were changing the opacity on. I've got options on how I do my interpolation. I can repeat that, so I can run it as many times as I want to set. So there's some basic controls here. And if I click on one of the keyframes now, I actually go to the properties for those. So here I can set the position and the value. So the position is non-dimensional, so you don't need to worry about setting an exact time. You only need to worry about how you're going to interpolate. And the value in this case for opacity is set to 1, so that's fully opaque. And if I go to my end keyframe at this point, I can click on that, get to those properties and say, all right, at the non-dimensional length of 1 for this sequence, I can set the value to 0. So I can quickly set up these properties just by navigating back and forth from the screenplay UI element, right back into the tree to set up the properties. And again, this is a big time saver. Another good one-action wonder, just a single sequence keyframe, is being able to change the view. View interpolations are hard if you've ever had to write them from Java, and it's hard to make them smooth. So within Screenplay, again, I can just grab the view and I can change the entire view so it can bring that entire block of coordinates in, where I can just focus on one of these to manipulate the view. But what's easy is just to say, all right, I've got a starting view. Let me grab that and save it as the property for this keyframe. Let me interactively move this object to the next position and just save the view with the right mouse click and drop that into my second keyframe. So I can interactively create a moving sequence very quickly. Another common one-action wonder is just being able to spin an object around. Again, with the osprey at the beginning, it would be great if we just were able to set up something where we could just turn that around. So we start with a front view and then go aft to look at the stern. In this case, there's a bit of a trick. What you need to do is set up a transform. And the transform is actually the thing that you're going to animate. And again, within the STAR-CCM Plus tree, this would be the object that's highlighted, and you could just drag this in. So in this case, I want to spin it around, so I'll define or grab the rotation angle And within that transform properties, I'll set up the rotation axis so I can spin it right around this mesh axis. The way you set this up then is inside your screenplay, we've got rotational transform. And in this case, we're modifying the transform of the object. Different interpolation mode here. In this case, you can choose something called spline. And what that does is a technique called ease in, ease out. So when you start the interpolation, it starts off slow. It picks up to a constant speed, and at the end of the sequence, it slows down again. This gives a better animation effect, if you will, for certain operations. So when you change that transform, that's part one. The second step is then to apply that transform to all the displayers. So in the animation that we showed here, everything is spinning. So I've got a displayer that has, or many displayers to which the same transform is applied. Now let's contrast that with, and here we go again, we see the entire tank rotating. Let's contrast that with just wanting to move the impeller blade. Now this is a transient simulation, and so we've saved the results in our solution history file. And in this case, we can take the solution view, drag the state index right into our keyframe sequence, and then animate that. Little handy trick here, there's a bit of frame rate math. If I want to save my animation out at 30 frames per second, and I want the duration to be 6 seconds, that means that I need 180 SimH states to populate that. If I don't line that up, then what you can see is some starts and stops as the interpolation tries to make its way through. The likelihood is that I probably know my SimH states. So after I set up my frames per second, all I need to do is specify the duration of this with this simple relationship. And again, that applies to our SimH or solution history because these do have integer representations for each state. Another good one is being able to sweep a cutting plane. Very common thing that you'll want to do. And there's actually 3 different ways to do this. One way is to just grab the origin of that plane, pull it into the sequence, and animate that. You saw this particular surface go from bottom to top. There's another way to do it, and that's animating the offset of that derived part. So when I do that, instead of looking at the origin, I'm just grabbing the offset, and it's exactly the same result. There's no difference in between these two. It might be easier if you have multiple planes just to manipulate the offsets. So you might want to combine all of those different derived parts in a single keyframe sequence, and that's still doable. The last piece is that maybe you've already set up a scene animation for your scene, and you can grab that scene animation and pull that right into your keyframe, and again, exactly the same result. So there's more than one way to do this, and the intention there is to be able to capture different workflows. Some people might have a preference for using the scene animation approach, and we've tried to support all the modalities to be able to do common actions. This also works really nicely with streamlines. So in this case, if I've got a rake displayer inside my scene, I can grab that and pull it into the scene. And when I do that, this gives me a nice way to animate my streamlines. Now, there's a lot of properties associated with streamline animations. So for example, I can set up a repeat. So in this particular animation, by picking the screenplay keyframe value duration to be twice as long as the streamline cycle time, I can get a repeat of 2. Simple math again, if I set the keyframe value to 12 instead of 8, I'd have 3 repeats. Now in this particular animation, the way it runs, the rakes start right after another, so it's a continuous repeat. But with a little change to, again, one of the streamline animation properties, I can set up a delay. So in this case, I'll see the animation of the streamline twice again, but there's going to be a gap in between the two. So nothing's happening, and then we see it again. So I can really manipulate this to suit what I actually need to do. Another very helpful capability is, again, one action wonder is to be able to manipulate warps. This is, again, another derived part, and I can just do the scale factor here just by pulling that directly in to the scene. So when I drag that in, again, single object in my sequence, and in this case, when I run my animation, I can see the deflection or the displacement of this object based on the scale factor. This is kind of an exaggeration of physically what's happening. And what's really handy here with Screenplay is you can say, okay, that scale factor is too big. Let me back that off to see if I can get something that's not absurdly deforming and still tells the story of what I'm trying to show. So those were a handful of what I call one action wonder, simple screenplays. And again, I want to stress it's important not to lose the value of those. You can whip these things out in a matter of minutes and have an animation. So instead of a bunch of pictures that you use hard copies for that you'd have to post in a report, you've got something that's a lot more vital. So I want to now step on to what I would call multi-action screenplays. So there's more than one thing that's going to get animated at this point. A good example to show here is an exploded view or an assembly view. And in this case, we've got the mixer shaft coming together. We show the mixing blades for this impeller. We're going to bring in the baffles next. So we'll show those in context to the geometry. And lastly, we're going to bring in the mixing tank. So there's actually a lot happening in this sequence. And from a keyframe standpoint, you have to figure out what I want to happen in what order. So this is an assembly from inside out, starting with the shaft and then proceeding up to the mixing tank wall. So when you're setting up more complex animations, one of the challenges is to figure out, all right, which goes first, which goes second, how do I want to set this up? And because I've got independent actions for the blades themselves and the baffles, I've got to specify which direction they're going to move in. So all the blades, in this case, there's 3 different directions that I need to specify, just for example. Same story for the baffles. They're all going in different directions. So what's involved here? Well, inside my scene, right, I'm going to need to set up a unique displayer for everything that has a unique motion or direction of motion. So here's all the displayers, my 4 baffles, my 3 blades, and my impeller, and then the top part of the shaft. For each one of these displayers, I need to set up a transform to tell it which direction it needs to move in. So there's a matching set of transforms to go with the baffles and the blades and the upper and lower parts of the shaft. So I need to set all those up. If I look at my storyboard for this particular screenplay, here's what it looks like. And one of the nice things about the UI is you can set up rows, multiple rows in your screenplay. So I've dedicated one row to just handling the mixing shaft, and another row to just do the blades, another for the baffles, tank wall. And in addition to that, there are some view interpolations that you need to include. I needed to include as well. So in this case, I can see pretty clearly that, okay, the first thing that's going to happen here is a shaft transformation. And there was a view transform that went along with that. I initialized my blades to make sure that the transparency wasn't on until I was ready to turn it on. So that happened here for all those blades. And then I used another sequence just to move those to attach to the shaft and so on. So there's a series of sequences in here that I can easily see and move back and forth, left to right, on this timeline to figure out the right order. I can also drag and drop and pull these keyframe sequences across rows as well. So that's just as easy to do. So this gives me a lot of editing flexibility. And as I'm evolving this animation, I can always use my scrubbing tool this tool to go back and forth to say, yep, that looks right, I have the order right. So that maybe is a little bit more advanced, but again, with drag and drop, it's pretty quick to set this sort of thing up once you've got a plan in mind of how you want to animate it. Here's another multi-action screenplay. In this case, what we're going to see is what I call the paint job. And I start off with a room to give the geometrical context, what's inside that room, so you can see the people and the furniture and the walls. And then the next thing I do is add a layer of information. So I bring in the temperature around the room. This ultimately is going to be an HVAC study to look at the placement of ventilation units within this room. But this is another way to present these results. The idea here is that I've actually got two scenes, one behind the other. And the way this works is I've got one scene getting wiped out while simultaneously I've got another scene getting wiped in. And that's it. So I've got some view interpolations in a keyframe sequence, and the steps to set this up, I've got two independent scenes. I'm going to link them together so that any mouse motion in one scene is also applied to the other one. I'm going to create a scene annotation, an image that I can use to place into another scene. And then I add that scene annotation in, and I'm going to put it in the background. So when I want to see what's underneath here, all I need to do is wipe away what's on top. So very straightforward, and it's kind of a nice animation technique to do a progressive disclosure here. You're revealing information by layers. In this case, one of the tricks here is, here I'm showing how you can do more than one object within the same keyframe sequence. And again, I can just click on that. This selector object or dialog comes up. I can pick the two things the two scenes that I want to link inside this view interpolation and just drag and drop them in. So we do need to have both of those scenes set up so that they move in sync as I'm doing the wipe. So that also includes the interpolation. But this is the entire sequence here. So it's a bit of a sleight of hand, but it's, I would argue, a very effective visualization. Next thing I want to show is something a little bit more advanced, and that is, how do you get a car to roll down the road? And the trick here is that you essentially move the road. So I can, again, set up a transform, and I can set up a translation and just drag that in here. And this is part of the keyframe sequence for this animation that you're seeing on the right. There's actually two view interpolations here. So I'm looking in one direction down the road while the road is moving essentially right to left. And then there's another view interpolation. So we can see that as we go down the road, there's essentially a pan and zoom kind of effect. Yeah, discussion question, why did I translate the road by this precise amount, 120.64 meters? Just because I wanted to see the duration of 60 wheel revs. Like, how far would a car get down that road? So if I don't have a road or a car on the road, I can do this arbitrarily and figure out in advance how I want this to look. Now, in this particular case, I've only got 4 full wheel revolutions. And I know that I've got 2 degrees of rotation for every state. And I've got 720 states. So similar to what I showed earlier, I've got a number of states in my solution history file. I pick a frame rate, and then that lets me calculate a duration. So in this case, I could write out an animation with the maximum time of 24 seconds. And that's kind of a best practice recommendation because it makes the animation look smooth, right? So the choice here is driven by the temporal fidelity, or how many states or steps I have in my time history files. But this is a good suggestion on how to set this up. As long as I maintain integer math here, that works. So if I want to go for a faster animation, let's say I set the duration to 6 seconds, I'm actually downsampling with respect to time. So again, that gives me another way to speed things up or slow things down as I need. So ultimately, what you end up with is something like this. So this is a case where I've got a lot of things happening in this particular example. I've seeded massed particles, essentially dust particles, inside the wheel wells here. And we're watching the fate of those particles as the wheels turn. Right? I could show just that animation without the road, but I think it's a little bit more effective if you see the car on the road. And you can pick up a lot of interesting information. There's a lot of visual cues, depth cues, so you can see reflections of the guardrails on the car surface. You can see the emissive lighting used on the taillights to make them look a little bit more realistic. You can see the shadows of the particles on the road. And that can actually be used to infer things like periodicity, how far apart these particles are as the vortex shedding occurs down the road. So in this example, there's layer upon layer upon layer of information. But again, with Screenplay, I've got the ability to be able to move things around, set them in sequence, and give what I hope is a very effective visualization of the fate of these dust particles in and around the wheel rims and the wheel wells. And Adam, I think I hope I'm on time here. So I'm going to wrap up. What I want to say.
You're
yeah. Okay.
That's perfect. Thank you.
So, excellent. So, my closing comments here, screenplays need some planning, but I think what's most important is to start with an effective visualization, just to be able to communicate results. Storyboarding is a good way to plan out what you want to do in terms of your animation. So I would encourage the use of that. I think the UI is well suited to do that. Don't forget the easy stuff. These one action wonder screenplays can let you do a lot quickly. And scrubbing can give you a quick way just to preview and gather trends. So you don't even need to think about saving these results. You may just get insights by just being able to interrogate with your scrubbing tool. There's drag and drop on this enhancement all over the place. If you're familiar with the STAR-CCM Plus UI, you know there's a lot of UI mouse miles running up and down that tree. We've tried to really hard to minimize this and to make it very obvious what you can drag into that screenplay editor with the color cues in the UI. So it's different from how other things work in STAR-CCM Plus, but we think it's a step in the right direction. And lastly, I think it's kind of good to keep in mind the basic taxonomy here. For some of us, it's brand new, and it might be a little bit intimidating, but I think with a little bit of practice, you can get the hang of it. So finishing up, there's a blog post out here that's got what I hope are some fairly compelling animations. So I'd encourage you to check that if you're interested. This scan, if you've got it up on my screen, I think you can scan it and it'll take you to the website directly. But I've also got the link there. So I think at this point, I'll stop talking, and Adam, I think I'll be happy to take questions at this point.
That is fantastic. Thank you, Matt. That was awesome. We appreciate it. I have a question. We're gonna unmute everyone now, and hopefully other people have got questions too. But I have a question, and that is, this all looks, very GUI driven. But I'm imagining a scenario where a user has kind of put a complex simulation out, maybe on a Rescale cloud resource, and is running in batch mode. Can these animations be created in that scenario, or do you need the GUI to be running?
So the way this would work, the screenplay is actually designed to not work simultaneously while the solver is running. We found we had some technical challenges with that, where we couldn't maintain state. And with interpolations, you need to be able to set a start point and end point. So the way you do this, and the way I made a lot of these animations was I ran them, and then I had, in my case, my solution history files, which are small. So even for this case here, I was working, it's transient data, but I didn't render it to take time away from my solve. So I just used the solve to generate this. I can rough out the screenplay on my desktop and figure out what I want to set up. But the solution histories are sitting on the cloud. So then It's just a matter of running a screenplay in batch with this content already computed. So that's the one thing to be aware of. But similar
Okay.
to animations, you go into wireframe, kind of a fast render mode for something like this, just to rough it out and get the right feel, and then you send it back to the cluster to do the full render.
Right. Excellent. Okay. Well, I appreciate that. That makes a lot of sense. And so let's throw the questions out to the audience. Let me, Jonathan, can you unmute everybody for me?
Absolutely. So everyone can now unmute yourselves. This is done along the bottom of the window. So if you're in the web interface, it'll be the bottom left is an unmute button. There's also a chat where you can enter chat questions. If you're in the Zoom application itself, not in the window where the screen share is playing, but in the other window that shows the participants, at the bottom of that is where you can find the unmute buttons and the chat. So we'd love to have any other questions right now.
It looks like, so anyone else, anyone got any questions for Matt? All right. What I'm hoping is that most of the users that we've got on this call will go away from today's presentation with ideas about how to do their own screenplays, and I'm sure that's got questions. Matt, from a support point of view, can people talk to you directly, or should they just speak to their DSE? Are they fully up on Screenplay?
DSEs should be fully up on Screenplay, and you can certainly ask them. You're welcome to communicate with me directly. My response time probably won't be as good as the DSEs, but I'm happy to answer questions on this. So by all means, it's okay.
All right, and I don't see any questions in the chat. So last call for any questions. Otherwise, we'll wrap up the meeting. Okay, excellent. Thank you very much for attending, everyone. Matt, thanks very much for a great presentation.
Oh, you're welcome. Thanks for the opportunity to share something that I'm really passionate about. So I appreciate that.
And just for everyone's info and yours as well, Matt, this will be recorded or has been recorded and will go up on the ATA YouTube channel now. So anyone who wants to revisit this or share it later can do that. And that might be especially useful for that barcode or QR code you put in there that people can use to go and look at these sites. So appreciate it. Thank you very much, everyone. And we will close the meeting.
Thanks all.
Bye-bye.